Alright, so in this video I'm going to look at the paper 2 multiple choice type questions. So I'm going to be talking through how I'm getting the answers to questions and also show you a few techniques for having a go at questions that you're not sure about. Alright, so let's start off with this one, so question number 5. And no, we haven't missed 1 to 4, those are just the written answers beforehand. I'm focusing just on the multiple choice ones here. Okay, so in which of the following do the quantities have the same unit? So with A, electrical resistivity and electrical resistance. So resistivity is calculated using resistance L and A, so those two aren't going to have the same units. Work function is a unit of energy. Planck's constant is joule seconds to the -1, so that's not going to be correct. Pressure is newtons per meter squared. Young modulus is newtons per meter squared, so that one is going to be the correct answer. Rate of change in momentum is a force, so a newtons, whereas acceleration is obviously meters per second, so that one's not correct. Alrighty, but obviously in the real thing, don't do as I'm doing here. You're supposed to shade in the box, but never mind. So, what are the number of hadrons, baryons, and mesons in an atom of 7,3 lithium? So remember that the number on the top line is the nucleon number, so your A, and then on the bottom line is your proton number, your Z. So it has only neutrons and protons, which are both baryons, so it's not got any mesons, so straight away we can eliminate these two, which claim it has mesons. So we're down to the last two here, and remember neutrons and protons are both baryons, so we've got 7 nucleons, so that means there's going to be 7 baryons, but both of them say that, and they're both hadrons as well, so there are 7 hadrons, which gives you C. The numbers aren't added together, so that one's going to tell you that one's not correct at the bottom. Okay, so let's move on to the next one. Okay, so electron capture can be represented by the following equation. Which row correctly identifies X and Y? So in electron capture, a proton captures an electron through the weak interaction, turning into a neutron and an electron neutrino. So particle X is going to be a neutron, so that eliminates these two. By convention you put the baryons or hadrons first and leptons second, so again that's going to tell you X is probably a type of baryon here. And to conserve lepton number we also need to produce an electron neutrino, so we know that one's not correct. So we've eliminated these 3, leaving us with this one at the end, our neutron and an electron. A calcium ion is formed by removing 2 electrons from an atom of 4020 Ca. What is the specific charge? So what we need to think is, essentially what we've got is 20 protons, we've removed 2 electrons, so we've got 18, and then we've got 20 neutrons. So on the top line we've got 2 positive charges, so 1.6 times 10 to the -19, that's on the top line, because you've got 2 protons essentially, and the bottom line we're going to have 40 times by 1.67 times 10 to the -27. So before we even type this into our calculator, we can look at these powers here. So clearly there's a considerably bigger negative number on the bottom line. That's going to give you quite a high power of 10. So what we're looking at a difference, 10 to the 7, 10 to the 8. So what that means is we can eliminate these two here, because we know clearly we're going to get something that's 10 to the 7-ish. So we definitely know it's not those two even before we've calculated it. And however, at this point, we're going to need to do a calculation because these two are both perfectly reasonable looking answers. So if you type those numbers in and do the calculation, you end up with 4.8 times 10 to the 6. So just a warning, sometimes you don't even need to do calculations, you can just look at powers of 10 and realise something is wrong. Okay, electrons and protons in two beams are travelling at the same speed, and the beams are diffracted by objects of the same size. So what does that mean? Well, they've got the same speed, so what we can say is that the velocity of the electron is equal to the velocity of the proton. And then the next part is linking it to the de Broglie wavelength. So let's remember we're going to get the de Broglie wavelength of the electron by doing Planck's constant over m times the velocity, and we're going to get the de Broglie wavelength of the proton by doing, sorry, that's the mass of the electron, the mass of the proton, and the speed of the proton. So we know when we're comparing these that these two are the same, and we know that these two are the same. So a proton's mass is considerably higher, which means it's going to have a smaller wavelength, or the mass of an electron is smaller, which means it's going to have a larger wavelength. So we can eliminate all the answers which say the opposite. So we've got, let's see, we can eliminate B because it says the wrong thing, and we can eliminate D because it says the wrong thing again. Okay, and then what can we see next? We want to look at the beam width, or the width of the diffraction pattern. So if you have a larger wavelength, you are diffracted through a larger angle. So you can see that essentially using the diffraction grating equation here. So if we look at this equation, we can see that if we increase the wavelength while keeping the other things the same, so this one and this one the same, your angle of diffraction is going to increase, so you're going to be wider, which is essentially going to mean that we are going for A here, because we've got the beam width being wider, or the angle of diffraction is larger. Okay, let's move on. So the intensity of a monochromatic light source is increased. Which of the following is correct? So when you remember, we used the photon model of light, where the photon energy is independent of the intensity, so anything which suggests the energy changes is going to be wrong. So we can get rid of those two straight away. And the number of intensity is the measure of number of photons per second, so if you increase intensity, you're going to increase the rate at which photons are emitted, or the number of photons per second. Okay, so let's move on to the next one. Which of the following is not true? Very standard type thing AQA does in multiple choice. They give you these which are these not true type questions. So each meson consists of a single quark and a single antiquark. That is correct. Each baryon consists of 3 quarks. That's true. And antibaryons are 3 antiquarks. What's next? The magnitude of the charge on every quark is 1/3. That's rubbish. The up quark, for instance, is 2/3. You can see that on your formula sheet. But let's check the last one. A particle consisting of a single quark has not been observed. That's true. You cannot get quarks by themselves. I won't dangle too much into that. If you're interested, go away and look at it, but quarks are always observed in minimum of pairs, mostly 3s or sometimes 5s with the new pentaquarks that they've discovered. Okay, so 2 points on a progressive wave are 1/8 of a wavelength apart. The distance between them is 0.5. The frequency is 10. What is the speed? So if we want to know the speed, we essentially need to know the frequency and the wavelength using the wave equation. So if essentially 1/8 of a wavelength is equal to 0.5, that would mean the wavelength was equal to 4. So velocity is going to be 4, the wavelength, times 10, which gives you 40 meters per second. So that's going to be that one there. Which one of the following waves cannot be polarized? So this is about identifying which one of these is not transverse, because longitudinal waves cannot be polarized. Radio wave can, because it's electromagnetic, which is transverse. Ultrasonic is a type of sound wave, which is a type of transverse wave. So this microwave is electromagnetic, ultraviolet is electromagnetic. So the correct answer here is B, because it's transverse. A diffraction pattern is formed by passing monochromatic light through a single slit. If the width of the single slit is reduced, which of the following is true? So, key thing to remember with a single slit, it's this equation that governs it, where A is the width of the slit. So if A is decreased, which of the following is true? So if it hasn't said anything about this, so I guess we can assume these two are constant, because it's the same monochromatic light and it's the same setup. So those are going to be constant. Obviously the 2 is going to be constant, which means the width of the central fringe is going to increase. So the width of the central minimum, so anything that says it doesn't, opposite of that will be wrong. So we can eliminate A and D straight away. And so we've got left with B and C, which describe the correct thing. And the intensity, well, if you think about it, if you narrow the slit, you're going to reduce the number of photons that can pass through. So you're going to decrease the essentially the intensity of the central one, because fewer photons can get through. So that gives you C. A light source emits light, which is a mixture of 2 wavelengths, lambda 1, lambda 2. When the light is incident on a diffraction grating, it is found that the 5th order of light of wavelength 1 occurs the same angle as the 4th order of light for wavelength 2. Lambda 1 is 480. What is lambda 2? So essentially what we've got is 2 equations. So we've got 5th order lambda 1 equals d sine theta. And we also have 4 lambda 2 is also equal to d sine theta. So what we can say is that lambda 2 is going to be 5 lambda 1 over 4. So it's going to be 480 divided by 4, which is 120, times by 5, which is 600. So 600 nanometers for that one. I'm getting a lot of C's for these answers. Cool. So the key thing here was recognizing that these two have stayed the same, so then you can equate the 2 equations to each other. 16. Which of the following is correct for a stationary wave? Between 2 nodes, the amplitude of the wave is constant. Rubbish. The amplitude changes to a maximum at the antinode and then goes back to 0 at the node. The 2 waves producing a stationary wave must always be 180 degrees out of phase. Rubbish. The separation of the nodes for the second harmonic is double the separation of the nodes from the first harmonic. So let's sketch that. That's your first harmonic, that's your second. So the separation of nodes is actually half, it's not double, so that one would be wrong. And 16, between 2 nodes, all the parts of the wave vibrate in phase. That's true. All points in here are at their maximum value, just like here they're all at maximum, and in here they're all at their minimum. So that's absolutely true, giving D is the correct answer. Moving on to question 17. So sound waves cross a boundary between 2 media, X and Y. So this is going to be a refraction question. The frequency of the waves in X is 400. And the speed of the waves in X is 330. And the speed of the waves in Y is 1320. What are the correct frequency and wavelength in Y? So the first thing is, in refraction, frequency does not change. That's just something you need to remember. So we can get rid of anything which suggests that it does, because it's wrong. So now we've got the frequency, we're in a position to work out what the wavelength is, because we're just using the wave equation. So it's going to be V over F. So 1320 divided by 400. We don't even need to do this calculation. We know the number is going to be approximately 3, so we can go straight to the answer here, which is C, without even doing the calculation. Question 18. Which of the following is a scalar quantity? Velocity is most certainly not. It's a vector. Energy is a type of scalar. Force is a vector. Momentum is a vector. So the answer would be B. These are things you just have to remember. Question 19. An object is accelerated from rest by a constant force F for a time t. Which graphs represent the variation of time with the change in the kinetic energy and the change in momentum of the object? Okay, so let's think about the two equations. So kinetic energy is half mv squared, whereas momentum is just mv. So what we're looking at is the variation with time as the velocity changes, and it's accelerated by a constant force, so that means acceleration is going to be constant. So the increase of velocity is going to be linear, which would mean the increase of momentum was going to be linear. So if we look at these options here, anything which suggests momentum is not linear is going to be wrong. The key thing here is your acceleration is constant, which makes velocity linear. So kinetic energy has a v squared, so that's going to end up being a quadratic type graph, which is going to mean it's going to be A for this one, because that's the only one that shows you a quadratic of the two options left. An object is dropped from a cliff. How far does the object fall in the third second? So essentially we're interested in the displacement at 2 seconds and the displacement at 3 seconds, and it's the difference between them. Okay, so the displacement after 2 seconds would be ut, but u would be 0, so we can forget about that. Essentially half a, which is 10 times 2 squared, so that ends up being 4 divided by 2 gives you 2, which is 20 meters. The displacement at 3 seconds is going to be half times 10 times by 3 squared, which gives you 90, 45 meters. The difference between those is 25, so it's going to be answer C. A body falls freely with negligible air resistance. What quantity of the body is its rate of change of momentum? Rate of change of momentum is a force, so we need to get rid of anything that's not a force, which is all of those, leaving you with the correct answer, which is D. So the next question is, you've got a firework and it's been fired vertically in the air, and when it's at its highest point it explodes. What are the changes to the total kinetic energy of the rocket and the total momentum of the rocket as a result of the explosion? So when it explodes, you're going to be transferring some kind of chemical energy into other forms. In this case, that's going to act to increase the kinetic energy, because you're transferring energy from chemical to something else. So you're going to increase the kinetic energy, so we can get rid of those two. However, if you think about it, in an explosion, no external force has acted on the rocket. So if no external force acts, you know that momentum is conserved, so the momentum cannot have been changed, so it's going to be C. 23. A lift and its passengers with a total mass of 500 kilograms accelerates upwards at 2 meters per second squared. Assume that G is 10. What is the tension in the cable? So the tension must be acting against the weight force and providing the resultant force. So it's going to be essentially mg, which is the weight force going down, and it also needs to be providing the resultant force, which is MA. So it's going to be 500, 10 plus 2, which is 12 times 500, which is 6,000 newtons. Okay, so let's move on to the next one. Which of the following is not a unit of power? So remember, power is a joule per second, and a joule is a force times a distance, so it would be Newton meters per second. And remember, a Newton is a kilogram meters per second, so it's in that meters squared seconds to the minus 3. So let's have a look at what we've got so far. So joules per second was one of the options, kilogram meter squared s to the minus 3 was one of the options, Newton meters seconds to the minus 1 was one of the options, but this one most certainly wasn't, so this is the one that's not a unit of power. Essentially, this is all about just breaking down your units into base units, one of the skills that's required. A car accelerates uniformly from rest along a straight road. Which graph shows the variation of displacement x of the car with time? So, if the acceleration is constant, your velocity time graph is going to look like that. So if you think about it, the displacement is the area under here, and the area under here is going to be changing in a non-linear way. So straight away we can eliminate x because we can see it's a triangle. So this area is not increasing in a linear fashion. We're adding bigger and bigger pieces. So if we're adding bigger and bigger pieces to the area each time, you'd expect the it to be an exponential increase type graph, which gives you B. C shows you're adding smaller and smaller bits, so C would correspond to a velocity time graph that looks like this, because the area essentially you're adding a smaller and smaller bit each time, so the gradient is getting smaller and smaller, and X would indicate the displacement's getting smaller, so that's clearly wrong. So let's move on. 26. Which of the following statements is correct? The force acting on an object is equivalent to its change of momentum. No, force is the rate of change of momentum, so that's rubbish. The impulse it receives per second. So impulse is the change in momentum, and so the change in momentum per second is absolutely the force, so it's that one. Let's just check. The energy it gains per second, that would be a power, so nope. Acceleration per meter would just give you a unit of s to the minus 2, which is not a force either, so that's rubbish. A load of 3 newtons is attached to a spring of negligible mass and spring constant of 15 newtons per meter. What is the energy stored in the spring? Okay, so the key here is to ignore the distractor, because if you look at the diagram you could easily get confused and start thinking about 2 springs. It clearly just says a 3 Newton force is attached to a spring of spring constant 15, so we can use the equation in this form, since we have both the force and the spring constant. So it's going to be half times 3 squared divided by 15, which is 4.5 over 15, which is 9 over 30. Divided by 3 gives you 3 over 10, so 0.3 there. This diagram is very distracting and very annoying, and if you answer it looking at the diagram instead of reading the question, you'll get this wrong. So be a bit watchful there. Diagram shows how the stress varies with strain for metal specimens X and Y, which are different. Both specimens are stretched until they broke. Which one of the following is incorrect? Okay, X is stiffer than y. So stiffness is the same as Young modulus, and Young modulus is the gradient of the graph. So x has a steeper gradient, which would mean that x has a higher Young modulus and is therefore stiffer than y. X has a high value on modulus, so that's the same essentially as statement A, so that's got to be true as well. X is more brittle than Y. Y failed with 0 region of plastic deformation, whereas X did have some plastic deformation, so actually that makes that statement wrong. Brittleness is how long a plastic region of deformation you have. Y has a lower maximum tensile stress than X. That's true. You can see the maximum it can experience before failure is lower, so that statement is correct, giving you an answer of C. 3 identical cells, each of internal resistance R, are connected in series with an external resistor of resistance R. So let's just sketch that. So we've got it looking like this. And then not to forget that we've got 3 sets of internal resistances as well. So the total EMF in the circuit is 3 times the EMF over R plus 3R. So that would be the current in the sense. The total EMF when they're all in the same direction is 3 times the EMF of 1, and this is the total resistance. When one of them is flipped around, essentially what happens is we've now got like this one instead of this one, and effectively these two cancel each other out, leaving you now with EMF over R, but the resistances are still in the circuit, so they still add together. So you can see we've got 1/3 of the current, so that's going to be answer A. So EMF sources in opposite directions will cancel each other out if they're equal to each other. Okay. In a cathode ray tube, we have 7.5 times 10 to the 15 electrons striking the screen in 40 seconds. What current does that represent? So remember, current is the number of charges per second, but remember it's charge measured in coulombs. So we've got 7.5 times 10 to the 15 times by 1.6 times 10 to the minus 19, and that's going to be divided by 40. So we're going to end up with a total of, you've got 10 to the 15 and 10 to the minus 19, so that gives you 10 to the minus 4, divided by something to the power of 1, so you're going to end up with something that's around 10 to the minus 5 there, so we can eliminate these ones straight away. I think it's best if we check the calculation at this point, just to double check. It should come out something as C, I think, but you never know. And divided by 40 gives you 3 times 10 to the minus 5, so yeah, it's answer C. Using a power of 10 can get you to the answer much more easily than actually doing a calculation. A cylindrical conductor of length L, diameter D, and resistivity ρ has a resistance R. What is the resistance of another cylindrical conductor of length L, diameter D over 2, and resistivity of ρ again? So first thing, to calculate the resistance of a conductor, we need this equation like this. And what we're going to do is we're going to rearrange it to get the resistivity, because we know it's the same for both of them. So we end up with this expression here. Now, the resistivity is the same, so we can equate the two equations for resistivity. So the resistance of the first one, which it tells you is R, would be resistance times the area divided by the length, and that's going to be equal to the resistance of the second one times the area of the second one divided by the length of the second one. So, first thing, tells you they're both length L, so we know these two L's are equal to each other. And it also tells you we've halved the diameter. So if you halve the diameter, that means your area is going to be a quarter of what it was before, because remember, diameter would get squared to calculate the area. So we can rewrite A over 2 as a quarter of A1. So now we can cancel the two A1s, And what we get left with is R is equal to R2 over 4. So we know that R2 is 4 times the original R, which is answer number B there. Answer number B? Ridiculous. Answer B. Okay, the cell in the circuit has an EMF of 2.0. So we've got a 2.0 volts there. The variable resistor has a resistance of 4.0 ohms. The potential difference across the terminals of the cell is 1.0 volts. So what that's telling you is you've got an internal resistance, and if we measured the potential difference across the cell, you'd measure 1.0 like this. So what it's asking you is, what is the potential difference across the terminals of the cell when the resistance of the variable resistor is 12? So the first thing to do is work out what the internal resistance is. So let's first work out what your current in your circuit is. So you're supplying 1.0 volts to your circuit, and it's across a 4.0, so it's going to be 0.25 amps. And so the internal resistance will be the potential difference lost across it, which is 1, divided by 0.25, and that gives you 4.0 ohms. And you could have got that straight away because essentially potential difference is being shared between the internal resistance and the external equally, so you knew it must be the same as the external resistance. So potential difference across the terminals of the cell when the resistance of the variable resistor is 12 ohms. So now the potential difference across the internal resistance will be the magnitude of it, which is 4, divided by the total resistance in your circuit, which would now be 16, and then times by the EMF, so we're just using a potential divider equation. So it's going to be a quarter times 2, which would be 0.5 volts. And so the terminal potential difference reading would be this, which is going to be 1.50 volts. So that one there. And the reason we can give it 3 significant figures is we can't, but it's multiple choice, so they're being annoying. Okay, so let's continue next question. So we're on question number 33. So we've got an IV characteristic like this, and we've got I on the y-axis and V on the x-axis. And it's fairly typical for a filament bulb. What is the resistance to the filament when the potential difference is 4.0 volts? So first thing we need to do is look at the two readings, because remember, resistance is V over I. Potential difference reading is 4. The current reading is 8 times 10 to the minus 3. So it's going to be 0.5 times 10 to the 3, or 500 ohms. So answer number A. And then last question. Which of these graphs shows how the resistance per unit length of a wire varies with diameter? Okay, so remember what we had earlier. So essentially we've got this equation. So the resistance per unit length, so the resistance per unit length is just the resistivity divided by A, which would be the resistivity divided by pi d squared. It would divide it by 4 because it's pi r squared, so that would go on the top line. So these are all constants. So what we've got is that your r over L is directly proportional to 1 over d squared. So we're looking for an inverse square type graph. So as d increases, the r over L is going to decrease, but in a non-linear fashion. So first of all, we're going to have it decreasing, so it's none of these increasing graphs, and it's not going to be linear because we've got a d squared, which is going to give you answer D, which is that one at the end. Okay, so those are the specimen questions. I hope you found that useful going through those and also seeing the methods that I'm using to approach these multiple choice questions. final thing I'd leave you with, make sure you answer every multiple choice question by the end of the exam. Seems obvious, but you'd be surprised how many students don't do it. If you're left with a minute at the end and you haven't answered a question, have a go. You never know, you might get the mark in it, and that could be the difference between a grade. So make sure you answer all the questions, and make sure you leave yourself sufficient time at the end of the exam to do these multiple choice questions. So aim to leave yourself about 2 minutes per question for these. Would be a rough guide. You can't always get quite that much, but somewhere around there is a good amount of time.